All right, everybody, welcome to DellyMaths Concepts. I'm about to go through some tips for your EOC Algebra 1, okay, final exam. So guess what? If you're new to this channel, like this video, subscribe to the channel, and share the video. All right, I'll be right back. All right, welcome back to DellyMaths Concepts. What we're looking at is solutions for or tips for the EOC Algebra 1 exam. So it says here the linear equation negative 2x plus y equal to negative 4 and the 3x plus y equal 5 are graphed below. Which is the best? And see, they said which is the best. Normally when we say this, we're not definitely gonna get an exact answer, but let us look. Which is the best estimate of the solution of the equation below? So I'm looking at A22. Right, let's look. So this solution is where the x is where the two lines would have intercepted. And as you could see, it's very close to positive 2. My x value is close to positive 2. So that means this is out, this is out. It's either this or this I'm thinking of. And then not only that, it's in the negative region, which means this is out. So we have to pick this. All right, so what we want to do is to eliminate answers that cannot be. And there are always two answers that are way off. You could eliminate them and you could zoom in, you would have a 50% chance. And then with a certain knowledge, you will be able to get it. All right, so C is the answer for that one. So you could see we're close to 2 and we're in the negative region for the y value, right? All right, let's go to number 2. The linear equation y is equal to 3 plus 2x and y is equal to 2 negative 3x. Our graph below, which is the approximate value of x in the solution for the system. So again, we want to look to see where the two lines would have intercepted, and right there you could see it's in the negative aspect because this is when x is 0. This line is where x is 0 right here, and it's to the left of it. So my x value must be a negative number. That's 1. So these two are actually out. What I'm looking at also is if we should put on some scaling here, this is negative 1, this is negative 2. This value that I'm looking at is not even going to reach negative 1 yet. So it's between 0 to negative 1. So I have to pick this for my answer because this one would have gone beyond 2. All right. Now let's go to the third question. Which is the best estimate for the point of intersection for the graph of 2x minus 4y equal 10 and 4 minus 6x equal to 2y. All right, for some of these, you could try the coordinates in and see if they work out, or what you can do is that you could set it up and try to do it and then pick. They did say best estimate, so we're not necessarily going to get the exact answer. So let us try to set up these. All right, so if I, right, so I'm going to multiply this one by 3 x values. I'm going to eliminate the x values. Take a look. So I'm going to get 6x minus 12y equal 30. All right, so I recreate a new or a third equation so that I could link these together. Now watch. So now I could link these. So we want to add them, right? We're going to add them. So negative 6 plus 6x, that's going to give me 0. This is gone. When we add this, we get negative 14y. And when we add this, we actually get positive 26. So y is 26 over negative 14. So as you can see, they said best. So let us see what we get for the y value. 26 divided by negative 14, that's negative 1.8 something, right? Negative 1.8. All right. So my y value is negative 1.9 when I round it off. So the fact that I get this already as negative, so I get negative 1.9 when I round this off, I'm going to just take this and I'm gone. So I just work out 1. I don't need to work out the rest. And this is one of the things that we want to do. When we find the unique idea, for example, there's no more negative 1.8, 1.7, 1.9. I'm going to pick the best one and move. So the answer has to be C. All right. Which is a solution of the system of equation? So here I have two inequalities. If I want to find the solution for the system, what I'm going to do is I'm gonna substitute the x and y's and see if the whole idea makes sense or it is true. So this is x, this is y, this is x, this is y, this is x, this is y, this is x, this is y. So I'm gonna start off with f. So I'm gonna take 2, 1. So take a look. I'm gonna put 2 where the x is here. So this is -2 right here. All right. And then I'm gonna see if everything is gonna work out to give me greater than 1, basically. Let us look. So if I have -2, let me rewrite this. This here, put it in the clear. I'm gonna substitute now. So if I substitute -2 here, this becomes +8, right? So y is 1, so I'm gonna put 1 here. 1 is less than 2 plus 8. Is that true? Yes, that is actually true. So so that means I'm ticking this, but I'm gonna have to check it on the other side here with this to see if it is correct too. So I'm going to check it with 6y, because it has to be true at both places, minus 9x greater than 15. Remember that x is -2 and y is 1. So I'm going to substitute. So let's go. 6 times 1, remember y is 1, minus 9 times -2. That should be greater than 15. Let us see. 6 plus 18. Is that greater than 15? If the answer is yes, that means this already worked for both cases. I don't need to try the rest. That means this is wrong, and this is wrong. Because what you're looking for is that one answer. They didn't say we have multiple answers. So right now we have one answer. And if I find something that works for both already, then I'm moving on. All right. Let's take a look at number 5. So number 5, I'm still on A22. Number 5 says the solution of which system of inequality is graphed below. Now you're looking at these inequalities below, and I'm just going to give you the hint how we want you to look at these. Remember, so I'm going to drop the hint to the side. I'm going to ask you to read from where y is all the time. It doesn't matter if x is over here. As long as y is there, you focus on that. The key thing is you want to read from where the y is. And it has to be a positive y too, right? So if I'm reading from where y is, if I read less than, it doesn't matter how the line is, you have to shade below the line. Below, right? And if I'm reading from where it says y is greater than, then my shading will be on top of the line. So it's two ideas right there when the line is slant. It's either you're on top of the line or you're below the line. Now, reading from where y is, we're looking for, if we say less than, we must see the shading below the line. If from where y is, you say greater than, the shading must be above the line, right? So let us see which one of these would have made sense. Now, when you look at the shading here, these shading that we're looking at, they are above both of the lines. Because for this line, you can see that the shading is above it. It's not beneath. And for this other line here, the shading is also above it, not below it. So what that means for my two cases, I want to see where y is greater than in two cases. So I see y is less than here. This is incorrect. Y is less than here, incorrect. These two are showing me where y is greater than. If you look at this, this says less than here, indeed. That would have spoiled that. So we're eliminating what cannot be. So I don't even need to work out anything for this one, but I'm looking at an idea where if I'm reading from where y is, if the shading is above the line, if the shading is anyhow above the line, then it has to be greater than. But if it is below the line, y will be less than. We're focusing on that, right? And so sometimes you don't have to work out anything. You just want to remember those principles. Let's go to A21. So we're going to A21 now, right? So let's see what the question is. It's a similar question, right? Let me minimize so we could look at everything at once. All right, right. It says here, which shows the graph where, look at this again. We want to show the graph where y is less than. So already for any one of this answer that I'm looking for, the answer, the shading has to be below the line. So I'm going to eliminate what cannot be. It cannot be this because the shading is above the line, right? And remember the key things reading from where y is. If you say less than, you're looking for, so this is a possibility. This is a possibility. This cannot be. This is a possibility. So we have two things, right? So we have B and D to now scrutinize. Now we're going to use the y-intercept now to help us. Remember at y-intercept, at all my y-intercept, right? X is always 0. So you want to substitute 0 in this to know your y-intercept. Take a look. If I put 0 here, I'm just saying, if I put 0 right here, you could see that my y-intercept is going to be at -2. So what I'm looking for now is a graph that the shading is above the line and it crossed the y-axis at -2. My bad. Where the shading is, we're looking for a graph where the shading is below the line and cross the y-axis at -2. All right, my bad. So this did not cross the line at -2, so B is out. So now it has to be D. And whether or not I see an answer, because look, you could see that it crosses there. But the fact that I eliminated 3 things already, then automatically the last answer would have worked. So let's see what the second question is like. It says here, which shows the graph of 3x minus 2y less than or equal to -8. Again, as long as y is on the side, right? And you're looking at this, you have to be careful. But again, remember now, we're looking at a positive y, right? Positive y. So what we want to do is just to eliminate some stuff here, right? We want to eliminate some stuff. Take a look. So again, because the y is a negative here, this is a -2y, then we're going to have to flip the sign, right? We're going to have to flip the sign. So then what this really is representing is greater than, because the negative here would have flipped this sign. All right. So let us see what's really going on. So let us put this in the right perspective. So why not just set this up so you could see properly, right? Take a look. So in this case, we're saying, let us get the y to be by itself. So I'm going to subtract 3x from both sides. Now I'm going to divide by -2. And when I do divide by -2, y, you're going to see that this becomes greater than. This is 3/2x. And then this is +4, right? So now I'm putting it in a perspective where, because the y was negative, I want to make sure that we're seeing it clearly. We're talking about greater than. So my shading must be above the line. Not only that, that this specific line must cross the y-axis at +4. So let's just take a look at what's going on. All right. So the shading should be above the line. So I'm going to eliminate, it cannot be this. That's below the line. It cannot be this. This is below the line as well. Well, these two now, I am going to think of. But remember, my y-intercept must be at +4. You could see that this one is at -4. So this is off. And then I'm going to have to pick this for the answer. And then you could see that it is really at +4. So those are some little key things that we could do as we go forward. All right. Let us go to A20. Let's go to A20. All right. A20 says here. It says here. It says in the ordered pair shown below, X is the number of hours that Chandra rent personal watercraft, and Y is the total cost. Which equation models the data? Now, all you have to do with this is to substitute. Look, this is X, this is Y, this is X, this is Y, this is X, this is Y, right? Now, all we're going to do, we're going to substitute the X values, all right, and see if it gave us the proper Y value. That's all. So remember, it's a coordinate. For example, Let us look. I'm going to go. I'm going to use, say I'm using 1 and 85. If I put X in as 1, I should get Y to be 85. Let's look. 1. So 1 plus 84 is 85. I feel good, but I got to check everything else to see if it works. So I'm going to have to use 3 and 205. It should work for everything. So if I put X here, 3 right here, we're going to have 3 plus 84. That is 87. I'm not seeing 87 here as a Y value. That means A here cannot work, because what you want, you want something that will work for all of these at once. It worked for A1 and 87, but it did not work for 3 and 205. So A is off. You're going to have to try it here again. So let us try it. 1, if you put 1 here, 1 times 60 is 60, plus 25, I'm still getting 85. So I'm like, okay, this doesn't sound bad. Let's try again with 3. So now you're going to have to, we will have to try 3 here. So 60 times 3, then plus 25. 180 plus 25. That's 205. So it's still going good. It worked for this, it worked for that, it worked for this. Let's keep going again. Let's try one more time. We're going to try 5 and see if it produces 325. So it's going to be 60 times 5. And then we're going to add 25 to it and see what we get. This is going to give me 300 plus 25. I'm getting 325. And you could see when I input 5, I get an output of 325. So let me just top off the idea. So it worked for here. So let me rephrase all this. What we're doing is we're going to take the points and we're going to substitute all the input. X is our input. So I'm going to put the inputs here, here, here. We're trying them there, right? But any one of these would have worked for all 3 points is already correct, right? So because all 3 worked here, when I put in 1, I get 85. When I put in 3, I get 205. When I put in 5, I get 325. That means it is the answer. For the others, 1 or more would be incorrect. Number 2, graph. The graph shows the distance that a Florida panther can travel. Which of the following best describe the slope? All right, so let us look. Distance on our y-axis, the days, right? So you have to focus on the idea, days. So in 1 day, let's follow this. 1 day, boom, 15 miles. So I'm looking for that. I'm looking for 1 day and 15 miles. This is saying the panther can travel 5 miles in 1 hour. I don't know about that yet. Panther can travel. I'm looking for this is it. So if I did not see this, then I'll try to break things down. A panther can travel 15 miles per day. I'm seeing that right here. So because I see that, I don't need to double check anything else, right? So let's go. Let us see what number 3 is. It says a Sam jogs around 100-meter track at a steady pace. The linear equation y is equal to 5x describe how many meters he can run after x seconds. Which of the following best describes the meaning of the slope? Now, watch this. Y is equal to 5x. Now, look what x is. X is the seconds. And then y is going to be the distance. All right. So then you can see here that this person is actually doing 5 meters per second. Right? He's doing 5 meters per second right there. And so for every second, you multiply by 5. So I'm looking for that. Sam runs a rate of 5 meters. I'll take B for the answer. It's 5 meters for every single second. That's what it really means, B. All right, let's go to number 4. Number 4 is the table. The table below, it shows the liters of water remain. Remaining is the word, remaining in the tank. So we have to be careful here. That is left back in the tank after it has been drained out. How many liters will remain in the tank after 16 seconds? So I'm thinking, right? I'm thinking. So if I say y is equal to 50 all right? Minus 50 minus, we're going to look at this. Take a look at these two ideas. Take a look. If you subtract this, I'm looking for the slope now. If you subtract this, you're going to get 6, 2. So we're talking about 6, 2. So watch this now. So the 6 divided by the 2 will give me 3 for 1. All right? So for every 1 minute, 3 liters is coming out. That's what this is saying. So I could have a 3x, meaning 3 is my slope. I just work out my slope right here, because we could have said x1, y1, we can say x2, y2, and you could still do this sort of idea. I'm just saying to feel comfortable. So you could see all that idea. You work it out there, and you're going to end up getting, all right, let's put it in. So 44 minus 50 over 2 minus 0. So you're looking at negative 6 over 2, which is negative 3. So that's what we're saying here, negative 3. So if you want to set it up, and you could say y is equal to negative 3x plus 50, whatever you want to set up, or 50 minus 3x, same thing. So basically then you want to input 16 here. All you're going to do is to input 16 there and see what you get. So we're talking about negative 3 times 16, and then you add 50 to it. All right? Negative 48 plus 50, and we're getting 2. So this is suggesting that you're going to have 2 liters in the tank. All right? So we're going to have 2 liters in the tank after 16 seconds, based on how it is, the rate at which it is coming out. So one has to read and then interpret and move on. All right, let's go. We're going to, let's go to A19. All right, so on A19, this page, we're looking at which equation represents the line that is graphed below. Okay, if I'm going to see if I could see the line as graphed below, firstly, I'm going to have to take a look at the y-intercept. So as you could see, my y-intercept is 1, 2, 3. So my y-intercept must be 3. So this is wrong. This is wrong already. Now I'm thinking these two. Which one? Now, apart from my y-intercept, I wanna look at the fact that if I understand the slope. Now, remember now, take a look. I have a negative 2x plus 3. I have a positive 2x plus 3. I don't have to work out anything. If my line sets like this, from bottom left to top right, this is a positive gradient, positive. But if the line sets like this, remember, then this is a negative gradient, or what we call slope. So right here, my slope is negative. My slope is positive right here. So which one will match my line? Since my line from left to right is representing falling, like I'm going downhill, then it has to be the negative slope. So this is the answer for the question. So without working, you could look at the ideas and the principles and you come up with it. All right. So we eliminate and then we zoom in and then we select. All right, let's go again. What is an equation of the line that passes through the point negative 4, 3 and has a slope of negative 1? Now, all I'm going to do is, why not just set this up into slope-intercept form? Remember, slope-intercept form says y minus y1 is equal to m, which is my slope, x minus x1. Now, label these. This is x1, this is y1. We're going to put them in. What is my slope? This is my m. So y minus y1, that is 3, is equal to m, which is negative 1. And then x, right? X, and then minus, right? Minus 4. So this becomes plus 4. I'm looking for anything like this. So when you set this up, you want to quickly just take a look at what's going on. So my answer is at H, as you could see right there. So so you set it up and then you take a look at what's going on right there. My answer is at H. Let's go for number 3. Which is an equation of a line that passes through the point negative 6, 8 and perpendicular to this. Now, here's a quick thing. When lines are perpendicular, all right, when two lines are perpendicular, one slope is the negative reciprocal of the other one. For example, this slope here is negative 2 over 1. It means that the line that is perpendicular to it will have a slope of positive 1 over 2. Positive 1 over 2, right? So it's going to be the negative reciprocal, right? Off. You flip it upside down, change the sign. So I already know, right? I already know what's going on in terms of my slope. So if I have a slope and I have a point, I can represent it again in slope-intercept form because my m is a half and my point is negative 6, 8. I'm going to represent this in slope-intercept form. Let's go again. Y minus y1, which is going to be 8, which is equal to m, which is a half, open parentheses, x minus minus. And we know that minus minus becomes a plus right here, right? So all I'm going to do then is I'm going to set this up to set it up like how they have it. Let's go. So if I distribute, I'm going to keep my y minus 8. Let's just distribute this inside, right? So we're going to have half x, right? And then half of 6 is plus 3. And then I'm going to have to add 8 to both sides now so that the y is alone. So I have half x. So already we're seeing half x plus 11. So here it is. There it is. And we could have actually picked this answer without working. So let me tell you what you could have done, right? Now, the moment we realize that this slope, so here is a quick thing. The slope is a half, positive a half. So which of these is a positive a half? This is not, this is not, this is not. This is the answer. Never had to work out anything. So I'm just using this to guide you to the fact that take a look. You would have gotten the answer whether or not you worked it out. So you could look at this and then remove what cannot be. So we're going to use a process of elimination, zoom in on the answer without working. So a lot of these questions, you may not require to work them, but you need some principle behind your thinking. Let us go. The table below shows the coordinates for the vertices, triangle RST. What is an equation of the line that contains RS, right? So the equation of the line that contains RS. Now, well, let us focus on this, right? So the equation of the line that contains RS, what we want to do is to zoom in on R and S. Now, here is R, here is S. So let us label these. We could say X1, Y1. You could say X2, Y2. Let us set up. Let us find the slope first to see. So the slope is going to be Y2 minus Y1 over X2 minus X1. What is Y2? That is 3 minus 6 over. What is X2? 3 minus negative 2 right here. What am I looking at? I'm looking at negative 3 at the top over. This becomes a plus, which is 5. So whatever line this is, I'm looking at negative 3/5 for my slope. Now, which one of these? This is not it. This is not it. This is not it. I'm not going to do anything else. And this is what we're talking about. I don't need to do anything else because this is the only one with a negative 3/5 as a slope. So I'll pick it for the answer and I'm going. The only thing I want you to focus on is the fact that we're dealing with RS. You're picking up the coordinates that link to R and S. Be careful, right? So the answer is actually F. Let's go for the next one, which is an equation of the line that passes through the point 4, 2 and is parallel, right? No, and it's parallel. All right, so watch this. So it says, which is an equation of the line that passes through 4, 2 and is parallel to the line shown below. So if it's parallel to this line shown below, then it simply means that the slope of the line is the same. So let me give the quick disclaimer. When lines are parallel, their slope is the same. So we could say parallel lines have the same slope. So if I know this slope, I'm able to pick up something. Take a look at this. So let's look. We go up 1 and across 1, 2, 3, 4. So up 1 and across 4. Up 1, rise over run, rise, run. So I'm looking for a positive 1/4, right? So then watch this now. So now we have that positive 1/4. I already know that this cannot be, this cannot be. So now I'm gonna have to decide, right? I'm gonna have to decide. Because look, I'm gonna put this is 0. So 1, 2, 3, 4, 5. The original line here, this line is y equal to 1/4 x plus 5. That's what this one is. Yeah, see here? The y-intercept for this line is at 5. We want a line that passed through this point, but it's parallel to this. Obviously, it's passing at 1, right? So, because there are only 2 of them with a 1/4. And this is how we answer these questions. I'm not even going to prove this. I don't need to prove this. What I need to do is to select what cannot be. So we know that it cannot be B because B is actually the line we're looking at. So that means our line would have passed somewhere here, right? And that is the answer right there, right there. 1. So my key features that I'm looking at, what is the slope, right? And then it cannot be the same line because they did say it's another line.